Okay, let's continue on with PowerPoint week 1, week 2 slides. Overall grades. So normally attendance is 10%. Since this is an online class, you just get that credit. Homework is 20% of your overall grades. Quizzes, you'll have 6 quizzes total this term. That's what I'm planning. 4 of them for the first exam. The first exam is on week 5, and it will only cover homework that we do on week 2, just hand sketching. Starting on week 3, we will be doing NX solid modeling, and that's what exam number 2 covers. Quizzes, the first 4 quizzes will be quizzing homework problems that you are given week 2. So after week 2, about the end of week 3 and through week 4, sometime in there I'll be giving you 4 quizzes just like the homework problems, and that will be quizzes, 5% of your overall grade. It doesn't really change your grade a whole lot whether you do really well or really poorly on the quizzes. It's more of a pre-test for the test. When you do the homework, the hand sketching homework, if you don't do well on the homework and you have a lot of errors and stuff, then you may wonder, well, am I going to do okay on the test? That's what the quizzes are for, to give you a chance to retry it and see if you finally understand the homework problem after you've handed it in, I've graded it, you've got it back, you look at it, maybe now you can put, 2 and 2 together and get 4. The final project report, the final project and the report is worth 25% of your overall grade. There's no final exam. We used to, in class, when we do it face-to-face classes, you work in a group. That would be very difficult, I think, on online. So everybody will do their own project. The 3 rules of sketching is 1, you do it freehand. We do have grid paper that you can either get from Blackboard. It looks like that. Okay, it's a Word document with a blue grid in the background. You can use your own centimeter graph paper if you want to. I also have isometric grid paper though, which is a little bit harder to find. If you want to use your own, you better find it online and order it. It's about centimeter, and the lines go this way, and straight up and down. It's called isometric grid paper. So you'll need those types of grid paper. That is on Blackboard under course documents. Word documents, it's called grid template, ISO and grid template, regular. So you can download those and print them out as many sheets as you need, or go buy your own centimeter graph paper. If you buy your own, you just have to title the first page of your homework. First title, you might have like 8 problems or 6 problems. It takes 3 sheets to do it. So you'll want to put on the top your name, your MECH100, and your section number, not A or B section, but you're either section 01 or 02. And then the due date is like a week after it's assigned. And then over here it says assignment W-A-. That's week, like week 2 assignment 1, week 2 assignment 2, and week 2 assignment 3. Second bullet here is make sure you draw proportionally. If the book shows a part that is 6 units wide and 4 units high, then you can draw it 6 high and 4 wide, or 6 wide and 4 high, or you can do it 12 wide and 8 high, but it has to be to the same proportion as the book has it. Make sure you redraw or resketch what they give you correctly. Line types must be used correctly, okay? So there are different line types, and we will get to those. Construction lines are thin, extremely light, and they're used for construction layout. If you've already maybe seen some of the videos on doing the homework problems, you'll see how I use those. But construction lines is just very light with the pencil. By the way, the best thing you can use for this for drawing is these number 2 pencils. They're a very soft lead, and they make dark lines and thick lines as you need them. Drafting, mechanical drafting pencils, sometimes it's hard to get a dark line easily without going over it several times. So just a regular number 2 pencil. Keep one sharp for your thin lines and one a little bit duller for your thick lines, and these work the best. You don't need straight edges, you need paper and a pencil. The grids help us to draw fairly straight lines and fairly round circles. Object, sometimes called visible lines, are your lines that represent the edges of a contour, the edges of a plane. Hidden lines are the edges of a plane in the background. So we use a dashed line to show that edge of a plane or plane and edge view. Notice that hidden lines 0.35 millimeters wide, object lines 0.7. I'm not going to take a micrometer and measure your line widths, but basically you should be able to tell that some are wider than others. So hidden lines and center lines are thin but dark, object lines are thick but dark, and construction lines are thin and light. So light and thin that if you don't want to erase them, you don't have to. We're not drafting, we are sketching. Drafting is done to be like very precise and pretty and finished drawings. And our drawings are not finished drawings, they're like mock-ups, they're hand sketches. We're just solving problems. So title blocks for a company that has construction drawings, title blocks tell everything you need to know about that drawing that isn't in the drawing, or dimensions or notes about the drawing. So title blocks show the owner of the drawing, whether it's GM or Ford or some architectural engineering firm or something. But you'll have things like the name of the drawing. Sometimes it's a sheet or sheet number, like M1 for mechanical and P1 for plumbing or something like that. You'll have the date on it, or maybe several dates. Every revision would be dated. Okay. For us, it's going to be the date, section number, your name. For a working drawing for whatever company you might work for, well, whatever they want you to put in the title block, that's what you do. It can specify part material, tolerances, scale, company name, revisions, and anything else that the company wants to store, like the AutoCAD file name, maybe the location of it, catalog numbers, who knows, whatever a company wants to store, they put that near or in the title block. Our title blocks are very very simple. We just put them up there at the top of the first page of the homework that you're handing in. Okay. So we'll be using 2 types of sketching. Orthographic, sometimes called multi-views. Orthographic views are 2-dimensional representations of 3-dimensional objects. So they're kind of a cartoonish drawing. It's only showing 2 dimensions, not 3. Usually a top, a front, and a right side are typical, but you could have a top and a left and a front, or you could have more. You might need a top and a bottom and a front and a left and a right. Okay, so you use as many views as you need to correctly dimension all features on the part. We will be working with basically 3 views though: top, front, right side. There's also different types of views listed there: sectional, auxiliary, or partial views. So we'll get into those later in the term. We also will be sketching isometric pictorials. So an isometric pictorial is a drawing where it is a 3D representation, 3-dimensional representation of a 3-dimensional object. Why do I say representation for orthographic and isometric? Because it's not exactly as the eye would see it, it's an approximation. Okay, it's a perspective. At the bottom there, oblique and other perspectives. There are other ways that people draw drawings. Single point perspectives, if you remember the old cave or dungeon crawl video games where they basically showed the dungeon or a hallway, and it kept getting progressively smaller and smaller and smaller, and it went down to a point in the distance, possibly. That's called a single point perspective. In architectural engineering, they use a 2-point perspective, which looks a lot more like what the real eye would see. But we'll be using oblique and not some other perspective that shows three-dimensional objects as a three-dimensional, drawing. So with orthographic views, how many, we already covered this, how many number of views do we need or is required? As many as is necessary to correctly dimension all features in the part, or on the part. We use hidden line conventions. In the book there will be a sheet that brings up, let me show you the sheet. So this is hidden line conventions. If you zoom in on this, if I can zoom in on this, not easily, right? You will see like B, little circle around B. Here's B. Here's what it looks like blown up. This is how we join corners of hidden lines. They touch, okay? This is how you don't do it. The hidden lines don't touch, so they just ignore the circle there. So with every one of these letters, they show you how to do it, how not to do it. Pay careful attention when you're looking at this drawing in the book, when you're doing the reading assignment, and make sure you understand how to correctly show crossing hidden lines and of features in the background, etc. Center line conventions. What does a center line look like? In the hand sketching of the homework, so the homework problems, week 2 homework problems, I do examples of center lines, so make sure you watch that video. Line precedence means if you have 2 lines on top of one another, maybe an object line, a hidden line, and a center line could be in the same spot. That means that hidden lines take precedence over center lines, so if you have a center line there and a hidden line goes on top of it, just don't even put the center line in. Hidden line takes over. If an object line is on top of a hidden line, the object line takes precedence over the hidden line. Don't even draw the hidden line in there. With an isometric on top, this shows you line precedence. Okay, here we have a hidden line for the edges of the holes would be there and there. A center line for that hole goes through, but it shows a hidden over the center line. Why? Why? Because that hidden line is this edge view of this plane right here. So it would also create a hidden line here. Hidden line takes precedence over center line. There you go. The only thing you can see of the center line is it's sticking out on the ends. Okay. Same thing is happening here. What does this hidden line represent? If you project over, you see it's the top of that hole, and the bottom of the hole is this hidden line. And the center line of that hole is here and here, but over top of it is an object line because this plane in edge view makes an object line or visible line across there. Projection between views. The first assignment, let's see, the missing view problems will be showing projection between views using reference lines and miter lines. So watch that video. This is just trying to explain in verbally what we're doing. I'll show you point numbering and lettering technique. An alternate arrangement of views. An alternate arrangement of views, typically you have top here, front below it, in your perspective, right to this side. Okay. An alternate arrangement of views would be if you have a front view here and a top view above it here, and you wanted to create a right side view over here, your perspective. But you don't have room because maybe you have something, notes are there already. You could take from your top view and project off to the right side. That's not called a right side top view or a top side right view. It's called an alternate view. Taking the side view of a top view would look just like a side view of a right, the right side of a top view would look exactly like the right side of a front view. It would just be rotated 90 degrees. So that's called an alternate arrangement of views. It's covered in your book, I believe, too. Down to number 6, different problem types, okay? These are the 4 problem types which you will be doing next week, week 2. Given an isometric pictorial, that's the first one, you'll have to draw the necessary orthographic views. 3 orthographic views, okay, 3 of them. Given 2 orthographic views, you'll need to draw the third view, called the missing view problem. Given 3 incomplete views, you have to complete the views. In those problems, you're given 3 orthographic views, but they're not complete. There could be 1 or more missing line in 1 or more views of 1 or more line types. So you could be missing center lines, hidden lines, or object/visible lines. You don't know how many, you just have to find everything. And the way you do that is you find every plane, name it, and then find a contour of a plane, name it, and then find it in the other 2 views. And if you can do that with every contour, you'll find every plane. That's one method of doing it. Given a multi-view, or an orthographic view, it's called a multi-view, sketch the isometric pictorial. So we'll be getting to all these problems next week. It's going to be a boatload of drawings, okay? Normally we have 1 of those drawings done week 1, but we're not allowed to do lectures on the first week because everybody's trying to get up to speed with this online stuff. Okay. Some definitions. You'll hear me saying, and this is for any class you take at Kettering, you may learn new words, new vocabulary. Sometimes you'll learn new vocabulary that means different than what you've known in the past. You all know the word true, and you all know the word length, but we put them together, true length, and that has a specific meaning, sometimes abbreviated TL. It means when a line appears as it really is. If this pencil is a line in space, when does it look in a picture like it's true length? Well, anytime you're looking perpendicular to it, it's true length. If you're looking at an angle to it, or it's at an angle to your point of view, then it's going to look foreshortened, or a shorter line. Okay, so true length line is whenever you're looking perpendicular to it. The point view of a line is when you take that line in space, or your perspective, and you turn it until you're looking endpoint to endpoint down the line. It then looks like a point in space. So that's the point view of a line. The true view, TV, true view of a plane, if my palm is a plane in space, it's kind of like a true length line. A true view plane is when you look perpendicular to the plane. From either side, but perpendicular, that is a true view plane, which means all lines on the plane are true length. The edge view of a plane, when you take that plane in space and you turn it, or you turn your perspective, your viewing angle, until you're looking straight down the edge of the plane. And then the edge view of a plane looks like a line. Foreshortened. You hear me use that term. Foreshortened means it's when a line or a plane appears shorter than it is. So if I'm looking straight at a plane, straight on, and then I tip that plane on one axis, it looks foreshortened. My hand looks shorter than it does here. If I tip it on another angle, it's going to look foreshortened again. Okay, so you can incline it, or you can incline it once, twice, 3 times, up to 3 times, and it's inclined. If it's inclined in 2 different axes, it's called oblique. A normal plane is a horizontal or a vertical plane. Vertical in this orientation or that orientation, and horizontal in the horizontal orientation. An inclined line or plane is inclined on one axis. An oblique line is inclined on 2 or more axes. The book calls an oblique plane a compound plane. An oblique line's oblique, an oblique plane is compound. But oblique and compound plane means the same thing. It's rotated on multiple 2 or 3 axes. Modified construction lines. We had our main 4 basic construction, or 4 basic line types. Now we have a modified construction line. This is used for point numbering. It's not really light, but it's not extremely bold and dark. It's used for numbering points and labeling things like that. Okay. Don't label things too small that you can't read your own writing. Maybe use a fine pencil or fine tip pencil, and make sure you can read your own writing. People confuse ones for sevens if you put a little flag on the one. Sometimes fives and sixes look so similar because they're so tiny. So make sure you don't sacrifice the clarity for the size. Break lines, short break lines and long break lines. Long break lines are used on partial plans to break the plan in half or to cut off half the plan. And we use a little line with a squiggly on it and continue the line to mean, hey, there's something over here where we removed it. That's called a partial plan. A short break line is used in section views. So when we get to section views, you'll see an example of a short break line. This is, somebody says, well, yeah, this is all well and good, but what's going to be on the test, the first test? Well, this is definitely going to be on the test. Okay, right here. Methods to aid visualization. These are the tools I will teach you to solve graphical problems. Okay, projection is a tool used with the reference and minor lines. Line types and line weights convey information. So line weights, line types, you have to know how to use them correctly, or when you draw a drawing for somebody else, they can't understand it because you're not following the rules. This class, Graphical Communications, is graphically communicating with somebody else. You're drawing a drawing that another person can understand. Even if they don't understand your written and spoken language, you can draw a picture if we all use the same rules and they can understand that picture. You have to follow those rules. So that's what this class is sort of teaching at the beginning. Number 3 and 4 go hand in hand. Basically, it means if you want to draw or solve for an isometric pictorial, you need all the multi-views. You might be given 2, draw the third, and then that helps you visualize and draw the isometric pictorial. If you have 2 orthographic views and you need to draw the third orthographic view, sometimes it helps to draw an isometric pictorial with the evidence you know from the orthographic views to finish and draw that third orthographic view. Trying to think of the isometric pictorial or think of a three-dimensional image in your head sometimes doesn't work. Notice there is no list, and there's no item in this list that says use your imagination. Use your visualization skills. We all have that skill to some extent or others. Some are good at it, some are not. But I do not teach you that. That's something that your actual visualization skill will increase as you learn the other techniques and learn these homework problems. But I won't teach you that skill because that is the one tool in your cyber toolbox, visualization, imagination. That's the one tool that is broken. Trying to use that tool always for every solution. All I can say is it will give you the incorrect answer or a partially incorrect answer as often it gives you the correct answer. You need to learn the tools that will give you the correct answer without giving you errors. Visualization is a tool best used at the end of a solution to check your work. Okay? Some of you will find that out not until you get your homework back and you find out you've done everything wrong because you just couldn't conceive the correct solution. So try and use these rules as I teach them, not your imagination. Okay? Not your imagination so much. Okay, number 5, related views rule. That shows you how you put your orthographic views, top, front, right side. Okay, that's how you put them, how you arrange them in relation to one another. That's the related views rule, which we'll get through when we do homework problems, when I show you some example problems. Number 6, it probably should be 6 and 7, but number, I number points in an orthographic view, and I letter planes. Okay? We don't letter or name lines because lines are identified by the endpoints. So point 1 and point 2, point 1, point 2, which means that's line 1, 2. So we just letter or number points and letter planes. Locate a single feature at a time in each view. If you're checking your solution and you say, well, do I have it done right? One way is to find a single feature in each view. Find a single feature, if it's a hole or if it's a plane or if it's a 2 points that define a line, and then find that same feature in the other 2 given views. And if it's there, you found it. And if it's not there, you haven't found it yet. You have to put it in. Usually that's kind of a tedious method. That's where you use your imagination, okay, possibly to look for all that. But really, if you follow some of the other things like naming and numbering points and planes, by the time you get to the end, you've already found everything. You don't have to look back at it. The last one is modeling. Sometimes it's just hard to conceive with all your tools, and you just have to build a model. And I've done that as an architectural engineer, a mechanical engineer working in the architectural engineering field, where I had light fixtures on a strange stairway that didn't go straight up, you know, in one flight at a time, all the same. It would do 2 flights in one manner, and then offset and do two flights in another manner, maybe a square or back and forth. And floor plans are kind of hard. Floor plans are 2-dimensional images. So when you're trying to conceive all the different floors of a stairway going up, when the floor of a stairway halfway between the first and second floor is not really shown on the same floor plan, right? It's halfway between that level when the stairs turn and go up another way. So it was very difficult. I was working on a 7-story building, and it's like, I don't know if I have the right count of fixtures on these stairways, because it wasn't showing on the plans correctly. So I had to build a little paper model. That was early in my career. Yes, I used to be an architectural engineering designer, where I designed mechanical and electrical systems, power and lighting systems for buildings, and on the mechanical side, HVAC, plumbing, domestic water, medical gases, whatever electrical and mechanical systems go in a building. That's not brick and mortar and doors and windows and carpet samples. Okay, I did all mechanical and electrical sides. That's my background. I did that for about 20 years before starting here at Kettering. Wrong way. How to sketch an ellipse in an isometric pictorial. That will come next week in an example problem next week, because you will have one of your parts you'll have to draw. One of your problems you'll have to draw an isometric of a cylinder. Okay, so you'll be drawing. Whenever you have to do that, you have a circle when it's on an angle in isometric, a 3-dimensional part. It doesn't look like a circle. It looks like an ellipse. Okay, so I'll show you how to draw an ellipse on isometric paper. And let's see what else we got here. When solving for a 3 orthographic view set, this slide you might want to refer to when you get to week 2 homework next week, and you're looking for something like, what am I looking for? This plane, what am I looking for? Well, this tells you type of plane: a normal plane, an inclined plane, a curved plane on one axis, like a vertical cylinder would have a curved plane. They're similar as an inclined plane and an oblique plane. So if you're looking in a 3-view orthographic set and you find a plane and you can name it in every view, a normal plane, and I make these comments in an example problem in the videos that you'll find on my YouTube channel. A normal plane in a 3-view orthographic set will, if we name the plane like A, you'll see A in all 3 views. You'll have 2 edge views for a normal plane. Say you have a horizontal plane. In the top view, it's a contour. In the front view, it's an edge view. And in the right side view, it's an edge view. So 2 edge views, 1 contour for every normal plane. If you're looking for an inclined plane, or defining an inclined plane, it will have 1 edge view in one of the views. And in the other 2 views, that inclined plane will be a contour. It will show the shape of the plane, foreshortened. If you have an oblique plane, it will look like a contour or a shape in all 3 views, no edge views. The point numbering technique, this is a write-up of some tips when you're point numbering and how to do it right. It's easier to follow the graphical solution, some of the example problems I do, but this might help you to understand it after you see it done once or twice. Go through this PowerPoint presentation and read this. It'll make more sense then. This was actually created by my brother Dale when he taught this class many years ago. And I took his PowerPoint notes, and I used this for years, and I went, you know what? People keep saying they forget how to do the numbering technique. So I did, this is small text here, I did a step-by-step, like a walkthrough of how to do the numbering technique. So it's written out, a written explanation of a graphical solution. Not really the best way to do it. Watch the example problems of week 2. And I'll go over the step or the numbering technique. But if you get stuck on your own, you don't want to go through the video, you could probably just follow this. It's kind of like a recipe, how to do it, okay? It won't make much sense to you just reading it until you've seen the process. So watch the videos. I think that's the end of these slides. Yes, it is. So I hope that was helpful. If it wasn't, watch it again. This is Professor Eddie signing out.